fifth question taken from textbook page 63. So here we have a suspension bridge, and the cables here we are given the function, which is this one, and it says that x and y are measured in meters, right? So let's take note. And then it says that the minimum point is on the road surface. So example, the minimum point might be here and it touches the road. Okay, so in part A we need to find the distance from the minimum point to one of the pillars. Okay, let's say the distance is this one lah. Okay, from the minimum point and one of the pillars, which is here technically the y-axis. Okay, so to find the length, what we can do is, if let's say we have the coordinates of this minimum point, we can actually use the x coordinate, because if we find the length here, it's technically the length that we want, which is this one. Okay, so now we need to find the x coordinate of the minimum point. But to find the minimum point, again, the thing that we need to have is the vertex form of the function, right? Because now we only have the general form. So in order to change from general to vertex form, we need to use the completing the square method. Alright, so let's go through the 3 steps of completing the square. So the first step is, if you remember, the value of x squared must be 1. So the things which have x, we need to factorize that value out. So here it's 1 over 400. Okay, so from x squared I take out 1 over 400, and this value of x I also take out the same value. So if you want to find how do I get this 400x, technically it's just x divided by 1 over 400. Okay, and then you'll get this value lah. So if you want to double check, you can just multiply this value back to the bracket to see is it this one or not. Alright, so this is the first step, and the second step here is we need to add the special value, right? So here we need to take the value of x, which is negative 400, divide by 2 and then square it. Then at the back we need to put the same number, it's just that we need to minus. Okay, so this is the second step. Third step is to combine the values that have square, which is x, and this one, negative 200 if you divide already. Okay, which is here. Okay, so these 3 values will become this thing. Then for this one, it's just simplification lah. So when you calculate, you get this value. So once we've done this one, you can just multiply this 1 over 400 back to the bracket here. Okay, so here you will get your vertex form. So here we will be able to find the coordinates of the minimum point, which is 250. So the x coordinate here represents the length from the pillar to the minimum point. So the distance between the minimum point to one of the pillars is 200 meters. And for part B, we need to find the height of the roof above the water level. So here, because here it says the minimum point is on the road surface, right? Okay, and it says we need to find the height from the water level. So I'm assuming the water level is x-axis. So the length we need to find is from the x-axis to the minimum point. Okay, so to find this length, technically we can also use the minimum point. It's just that this time we are finding the y coordinate, because this y coordinate, it represents the length from the road to the water level, right? This length. So here we just need to find the y coordinate of the minimum point. So in part A we have already found it, so we can just write out a conclusion. So the height of the road from the water level is 50 meters.